1 second. You might think, what is the importance of knowing the O-level paper structure now itself? But it is actually really important. Yes, you get term tests. Term tests are very good evaluations for you all. But at all the time, you have to keep in mind that your end goal is O-levels. O-levels is end goal. Okay? The paper structure it's very important. So I will screen share one paper for you all, just for us to go through. We'll take like 5 minutes for this. I will share the 2020 paper. Let me screen share this paper with you all. And ogolang grade 10, grade 11 mula indamma get the O-level past paper book. Vadima papers ganak tiyana me book එක ගන්න. Okay? 1 second. What happened? Wait. All right. Can you all see the screen? Can all of you see the screen, Lamai? Okay. So your maths paper, O-level maths paper. There are two papers, paper 1 and paper 2. Paper 1 eකට 2 hours හම්බ වෙනවා. මම කොහොමද මේක බෙදෙන්නේ and how are you going to practice doing questions? කොහොමද time කරන්න කියලා මම කියන්නම්. But there are two parts. Part 1 has 2 hours. So part 1 එකේ තියෙනවා, paper 1 එකේ තියෙනවා part A. So part A has like small 25 questions. ඔක්කොම එතන උත්තර ලියන්න තියෙන්නේ. It's very simple. Then part B එකේ තියෙනවා structured essay. That means you have to write the answer on the paper itself. There are 5 such questions like this. Then comes paper 2. For paper 2, you get 3 minutes with an additional 10-minute reading time. Okay? And there are altogether 10 questions, right? 12 questions. Part A ke questions hayak tiyena, you have to do 5 questions and you can leave 1 question. Then part B ke, again, there are 6 questions. You have to do 5 questions and you can leave 1 question without doing. Okay? So if I were to tell you how the time is allocated for each question, I will go back to the whiteboard for this. Okay. Whiteboard එක පේන්නේ නැති කවුරු ඉන්නවා නම් I will put the link in the main chat. You can click on that link. Okay. So O-level maths paper. You have paper 1. Paper 1 has part A. In part A, you have 25 very small questions. Podi questions there. Then you have part B. Part B has structured essay questions. There are 5 such questions, right? Part B has 5 questions. So all of these are compulsory. All of these you have to do. Then there is paper 2. Paper 2 has, again, 2 parts, part A and part B. Now, Lama, in paper 2, all the questions you have to do on a separate piece of paper. So here there are 6 questions. From these, you only have to do 5 questions. In part B also, you have 6 questions. From this, you only have to do 5 questions. Now, let's see how time is allocated. මොකද ළමයි මම ඔයගලන්ට homework වලට past paper questions කරන්න දෙනවා. ඒකින්ද ඔයගලන් within a week වගේ past paper book එක අරන් තියාගන්න. So paper 1, as I told you, you get 2 hours. Okay, so 2 hours bedenne, you get 1 hour for the part A and 1 hour for part B. So you get 1 hour for part A and you get 1 hour for part B. Okay. So part A, there are 25 questions, and so all those 25 questions you have to do within 1 hour. So here 1 hour means 60 minutes. In part B, there are 5 questions you have to do on the paper itself. Okay, on the paper itself. එතකොට එක question එකකට කොච්චර time එකක් යනවද? So altogether there are 60 minutes. You have to do 5 questions. So roughly how much time is allocated for one question? Roughly 60 divided by 5. Roughly how many minutes? Quickly tell me. Yes, roughly 12 minutes. Give me a Okay. Then for paper 2, you're getting 3 hours. 3 hours kiyanne altogether 180 minutes. So that means you get 90 minutes for part A and 90 minutes for part B. මේක ඔයගලන් ස්ක්‍රීන්ෂොට් එකක් ගහගෙන ළඟ තියාගන්න. You are going to need this for sure. මම මේක ආයෙ කවදාවත් ඔයගන්ට කියන්නේ නැහැ. Later we are only going to learn how to time, but I will not give you this entire breakdown again. So part A, you have to do 5 big questions and you have altogether 90 minutes. So roughly how much time do you get for one question? Divide කළා රගල කියන්නේ. This is also maths. Roughly how much time for one question? Yes. Come on, lamai. You get 90 minutes for part A. There are 5 questions you have to do. Then how much time do you get for one question? About 18 minutes, ne? About 18 minutes. Same with this. Ekite wagemane, same here. Did you understand this breakdown? Give me a thumbs up. You guys are not very responsive today. Respond karanna. Denuri, Dinuki, eyes okay. Dinuki? Okay. And now I will tell you, this is a time breakdown, this is a paper breakdown. Api gedara practice karaddi kochara kohomada practice kara. Okay? Because I will give you homework questions now. Then you have to time those questions and do. We have to start grade 11 mula indala, right? So lamai, it's not like how you do questions during, like at home or during the class. At the exam, you of course have a lot of stress and like a lot of maybe anxiety or whatever. And international schools yana kattiyata wenawama schools wala thamai ogalage exam station එක තියෙන්නේ. Then it's a new environment, it's unfamiliar. So however much time you practice for one question, at the exam, you are definitely going to consume more time. Because you need time to adjust to the environment, you need time for that whatever stress or whatever, right? ඒක හින්දා මේ time එකටම අපි practice කරලා ගියොත් එම මීට වඩා time එක යනවා අපිට exam එකේ answer එක ලියන්න. Therefore, අපි practice කරනවා ඊට වඩා අඩු time එකකට. In paper 1 part A, for the 25 questions, you get 1 hour during the exam. But when we are practicing at home, we have to practice doing these 25 questions within 45 to 50 minutes. අපි ගෙදර practice කරද්දී we have to practice doing all these 25 questions within 45 to 50 minutes. එතකොට exam එකට ගියාම ගානට අපිට 1 hour වලට adjust වෙන්න පුළුවන්. Okay? In paper 1 part B, for one question you get 12 minutes. When we are practicing at home, we have to practice to do this within 8 to 10 minutes. එහෙම තමයි දැන් Bakaling batches වල since 2019 I've been doing classes, so all those previous batches they practice like this. So මුල කාලේ 10 minutes වගේ යනවා, ඊටත් වඩා යනවා, but අන්තිම කාලේ වෙනකොට 6 7 8 වගේ minutes වලින් ඉවර කරගන්න පුළුවන් වෙනවා with the practice. Then part A, part B in paper 2, for one question you get 18 minutes, but when we are practicing, we are going to practice for 14 to 15 minutes. One question we are going to practice to do within 14 to 15 minutes. So ගානට එක balance වල exam එක අපිට 18 minutes වලින් කරගන්න පුළුවන් වෙනවා. So of course there will be like adjustments, සමහර questions වලට පොඩි වෙලාවක් යන්නේ, සමහරට වැඩිපුර වෙලාවක් යනවා, but අපි මේ විදිහට practice කරාම we will be safe nevertheless. Okay? Is that clear to all of you before we move on to the lesson? Others? Hasindu, Denuri, Dinuki, Randira, Risindi. Okay. If you all want to, you can take a screenshot, but I will anyways put a image of this in the group. At the end of the class, I will put this to the group. Lessons coming to the paper, we will do as we go. This is too soon to discuss the lessons, because even if I give you the names of the lessons, some lessons you don't know and you're not familiar, right? So we will do it as we go. Some are lessons of the monkey and so that's something we can do as we go. And in July or August, when we start the past paper revision, lessons breakdown. But this is the paper breakdown. We need a paper breakdown because I will be giving you past paper questions as homework. Okay? Okay. All right. Put the topic real numbers. We are starting today's lesson. Put the topic real numbers. Okay. All right. Okay. Now, Lamai, in real numbers, we are going to be learning about, it's all numbers at the end of the day. Numbers are numbers. Api 1, 2, 3, 4, 5, 6, 7, 8 kyan puluang. 0 is a number. Then even if we take minus values like -1, -2, -3, -4, -5, -100, they are all numbers. And then decimals, they are also numbers. Ne? 1.24, 12.75. -2.35. These are decimal numbers and they are still numbers. Fractions, again numbers. 12, 1 over 2 or 5 over 6. So they are all numbers. So numbers are numbers, but these different types of numbers, we are going to learn how to classify them. Likewise, we are going to learn different names. So actually here there's a bunch of terms that we need to know, but this is a very easy lesson. So you don't have to worry about that. Okay. Now, first of all, we are going to be learning something called integers. Okay, don't write anything, just listen. There are a set of numbers that we call integers. Okay. Now, let's say there are okay, in your pencil case, you have some pens and pencils, right? So if I ask you to count the number of pens you have, how would you count? You say 1, you say 2, you say 3, you say 4, 5, 6, 7, likewise. Will you ever say, let's say, 1.5 or 2.5? Will you say like that? 1.5 or 2.5? How many pens do you have, Kira? Yes, we don't call it that. Api hema kiyanne. Right? Api kiyanne just 1 or 2 or 5 or 6 or whatever. We'll just count. Or let's say, api kiyamu, how many bags do you have? You say, I have 1 bag, I have 2 bags, I have 3 bags. So those are counting numbers. We just count, right? 1, 2, 3, 4, 5. We don't talk about fractions or decimals there. And counting numbers were topic here, positive integers, right? 1, 2, 3, 4, 5, 6, and so on. These are called integers. Positive. See, they're all positive. Plus, 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 plus. Everything has plus, right? So we call them positive integers. positive integers. So these are also called counting numbers. අපි count කරන්නේ මෙහෙම. Positive integers have a symbol. Integers වලට අපි use කරන symbol එකක් ළමයි z කියලා. The symbol of integers is z. So මෙන්න මෙහෙම මැද චූටි ඉරක් එක තමයි අපි z ලියන්නේ. If it's positive integers, we put a plus here. So these are all positive integers. Okay. So it's not just positive. There could be negative values too, like -1, -2, -3, -4, -5, and so on. There could be negative values as well. Still, there are no decimals or fractions, just numbers. -1, -2, -3, -4, -5, and so on. These are called my negative integers. These are called negative integers. Monat liyanne pa, don't write anything. And as I said previously, integer symbol is z. The negative integer symbol means we put a minus here, indicating that it's negative. Is there something missing here? What is the number that is missing here? Anything that is missing here? Okay, passing to others. Okay, Chenuli. Yes, Sahiru. Yes, it is a 0. Yes, Metna. 0. Yes, Denuri. Yes, Dinuki, it's a 0. Right. Etakota, now 0, can you see that 0 doesn't belong to positive integers? Ne? Up 0 can positive and 0 doesn't belong to negative integers as well. 0 is just there. Like 0 is not a positive integer, 0 is not a negative integer, it's just there at the middle. May positive integers and negative integers along with 0, collectively we call them just integers. Just integers. And symbol of integers is just z. Like this. Okay. So simply said, Lamai, integers can be whole numbers. Right? No decimals, no fractions, just a whole number. It could be minus, it could be 0, it could be plus values. They are whole numbers. Right? Remember, integers, we don't talk about fractions, we don't talk about decimals. So all of these together, we call them integers. The symbol is z. Etara positive kattiyata kiyana api positive integers, the symbol is capital Z plus. The negative values, we call them negative integers. The symbol is capital Z minus. And 0 is just there at the middle. 0 belongs to integers, but 0 is neither a positive integer nor a negative integer. Is that clear, Lamai? Give me a thumbs up if you understood that. And if you didn't understand that, let me know in the chat box. So unmute and let me know. Randira, Dinuki, is it clear? All right. So let's start writing that. Api step by step yamula maya. So let's start writing that. Here, write. Put a star and write. No. Let's first put a subtopic. So you put the main topic, real numbers, under that. Api subtopic ak dagana integers here. Subtopic integers. Capital Z. Integers are whole numbers. Here. And then we will write this. I will move this here. 1 second, Lamai. Okay, quickly write. Just a point, integers are whole numbers. You know, in maths, there are no like long notes. Just a point, integers are whole numbers, and then write this. Then I will give you something else to write after this. Quickly write. And then at the end, we will write something like this. So all of these numbers, Lamai, we can express them as sets. Do you remember in grade 10 we did sets, right? So for an example, if I say integers, the set integers, I can write the elements as, I will open the curly brackets. I can write the positive integers. The set of positive integers you can write as 1, 2, 3, 4, 5, and so on. So මේ ලියලා තියෙන එක මම set එකක් විදිහට express කරා. Okay? And then a set of set of negative integers I can express as, this is the integer symbol, minus. I will express as -1, -2, -3, -4, -5, and so on. Then just integers කියලා ගත්තාම integers කියන එක කොහොමද මම express කරන්නේ? It goes from minus to 0 to plus, right? So I can write -3, -2, -1, 0, 1, 2, 3, and so on. මෙතන ඉස්සරහත් කට්ට ඉන්න පුළුවන්. -4, -5, -6, -7, likewise. So this is how you express integers. This same integer set you can also express like this. මෙන්න මෙහෙමත් මට මෙයාව express කරන්න පුළුවන්. How? I write 0. Let me zoom this in so that you can see clearly. 0 plus -1. Plus -1 can lamai plus 1 ut tiyena, minus 1 ut tiyena. Then we can write plus or -2. That means plus 2 is included there, -2 is also included there. Then I can write plus or -3. That means plus 3 is included, -3 is also included. Then I can write plus or -4. That means plus 4 is there, -4 is there. Then plus or -5. That means plus 5 is there, -5 is also there. And so on. Eka මෙහෙම ලියන්නත් පුළුවන්. Both ways are possible. Okay? Did you all understand what I said? If you have any questions, let me know. Quickly write this, Lamai. Okay. මම මේ ටික ලියන්න time එකක් තියන්නද ඔයගලන්ට so that you can write faster. It will help with the speed. I think I'll give you 4 minutes. Quickly write. At the end, if you need more minutes, I will give you. But for now, quickly write. 30 seconds. Okay, Lamai, done? Give me a thumbs up if you have finished. Give me a thumbs up if you have finished. Anybody who needs more time? All right. Great. Good. So these are integers. So integers are now we understood. Huh? Now we are going to learn something called natural numbers. Natural numbers are really easy. Natural numbers kiyanne me positive integers walata. So now integers means there are negative integers, there are positive integers, and there's the zero. ඒ ඔක්කොම එකතු වුණාමනේ අපේ integers කියන්නේ. However, just positive integers from 1 to 3, 1, 2, 3, 4, 5, 6, so on, those only we call natural numbers. So that's very easy. Put a topic natural numbers. Just like integers, put a subtopic natural numbers. So you can write a point. So the symbol for natural numbers is capital N. So that includes, if we represent it as a set, the positive integers වල set එක මේකනේ. ඒ වගේම තමයි natural numbers. It's the same thing. So 1, 2, 3, 4, 5, 6, and so on. So that is natural numbers. Okay, quickly write that. All right. Done? Okay. So we did integers, we did natural numbers, and now we are going to learn something called rational numbers. Rational numbers, right? So let's put a topic and then I will explain after that. Topic එක දාගන්න rational numbers. Rational numbers. Put the topic and then we will discuss and then we'll write later. Just put the topic. Okay, Laman. Rational numbers wala symbol is capital Q. So integers wala the symbol was Z, natural numbers it was N, rational numbers it's Q. So rational numbers api menna mehema describe karana, right? How do we describe rational numbers? Let me write it first and then I will explain. So you might be confused what this is, but just bear with me. Yeah? Okay. So rational numbers rational numbers are fractions. So like, in a fraction, there is a numerator and there's a denominator, right? If you take a fraction, any fraction, like for an example, let's say A over B. The top part of the fraction, we call it what? Top part of the fraction, we call it what do we call the top number of a fraction, the top part of a fraction? Okay, others? Okay. Yes. It is called a numerator. The bottom part of a fraction called? The bottom part of a fraction is called? Yes, good. Now good na? Then ඔයගොල්ලන් ගොඩක් answer කරනවා. Denominator. Good. So the top part of a fraction, we call it the numerator. The bottom part, we call the denominator. Here, both these, the top part and the bottom part, both of them have to be integers. That is one requirement. Rational number එකක් වෙන්න මොනවද තියෙන requirements කියලා තමයි අපි කතා කරන්නේ. So for a certain number to be a rational number, it needs to be a fraction with a numerator and a denominator like this. And also, the numerator and the denominator should be an integer. මොකද්ද මේ e කියන symbol එක? E means it should be. It is included in කියන එක, right? So what it means is that A and B or numerator and denominator should be included in the set of integers or should be a part. Should be a part කියන එක. So A is the numerator, B is the denominator. They should be a part of Z. And you know Z means integers. So A උයි B උයි දෙන්නම අනිවාර්යයෙන්ම integer එකක් වෙන්න ඕනේ. A and B, both of them must be integers. However, B, which is the denominator, B cannot be 0. So these are our conditions. So any fraction or any number that meets these requirements, we call it a rational number. Okay? Rational number, it has to be a fraction where the numerator and the denominator, both of them should be integers, and the denominator cannot be 0. All right. So I will give an example. You guys, let's work it out, whether it's a rational number or not. Example. Number 1. If you take this number, this is 2. Do you think, just, you can take a guess, we have not learned it. I mean, we are just discussing now. So do you think number 2 is a rational number or not? Is number 2 a rational number or not? Okay. We got 3 answers, 4 answers. I need all of you to respond. Doesn't matter whether it's correct or wrong. It's just about interacting. Okay, 5 answers, 6 answers, 7 answers. So, is this a fraction? This is just number 2. Ne? So, I told you at the very beginning, rational number, it should be a fraction. Kiela. But is number 2 a fraction? Yes. Number 2 is a fraction because we can write number 2 as 2 over 1. Number 2 කියනක ඔයාට ලියන්න පුළුවන් 2 over 1 කියලා. And 2 over 1 is in fact a fraction. Yes. So it is a fraction. A and B or numerator and denominator should be integers. බලන්න. Numerator is an integer, that is number 2. Denominator is also an integer because it's 1. Okay, both are integers. That's all right. ඊළඟ මොකද්ද? Denominator should not be 0. එකත් හරිනේ. Denominator is not 0 and it's 1. එහෙනම් therefore it is a rational number. Therefore this is a page. We'll say therefore this is rational. Rational or not rational කියලා අපිට mark කරන්න පුළුවන්. Number 2. I will say can you guys work this out and tell me whether you think this is a rational number or not? The number I'm giving you is 4 over minus 3. Can you all tell me whether this is rational or not? I got one answer. Okay, Pasindu. Okay, Risindi. Others, what do you think? Just a yes or no question. Okay, Metna. Okay, Chenuli. Okay, Dinuki, Denuri, Aiza, Randira. Okay. Ugalan Godakai Kena, yes, Sahidu. Ugalan Godakai Kena, it is rational killer. We'll see. Is this a fraction? 4 over minus 3. Yes, it is a fraction. Are the numerator and denominator both rational? Sorry, integers? Yes. 4 is an integer. It is a positive integer. Minus 3 is also an integer. It is a negative integer. Okay, works. Is the denominator not equal to 0? It is not equal to 0 because it's minus 3. This is also rational. Great. Then let's say something like do you think this is rational or not? Do you think this is rational or not? Okay. Others? Okay. Good. Others? Why do you, okay, so a lot of you say it is rational. I can't see a fraction here, but why, I'll be open to your answers. Why do you say it's rational? Why do you say 0.5 is rational? Metra fraction ekak naha. There's no fraction here. I mean, you can write it as a fraction, or have I make a fraction ekak vidira liwuwot ehema 0.5 over 1. This is not an integer, no? Numerator is not an integer. එතකොට මේක rationalද? So I gave you 0.5, no? 0.5 වට ලියන්න පුළුවන් as a fraction, which is 0.5 over 1. So you have a fraction, but not, I mean, having a fraction is not enough. The numerator and the denominator have to be integers. Here, denominator is an integer, of course, but the numerator is not an integer. It's a decimal number. It's not an integer. So why do you say it's rational? I'm getting answers. Yes. 0.5 you can write as 1 over 2. 0.5 can half, ne? 0.5 can half. You can write it as 1 over 2. This is what you can do. මෙයාව 10 වලින් multiply කරලා මෙයාව 10 වලින් multiply කරොත් අපිට එනවා 0.5 multiplied by 10 is 5. 1 multiplied by 10 is 10. 5 over 10. See, it's a fraction. On order make it simplify, you can leave it as 1 over 2. See, it's a fraction. Numerator, denominator both are integers, and the denominator is not 0. So yes, of course, this is rational. Great. How about this? Now you guys can tell me whether this is rational or not. Make it faster. Okay. Okay. Others, come on, fast. Yes or no? Rational or yes, not rational or no? Square root of 16, we have a definite value, no? Because 16 is a perfect square. So the square root is a definite value. Api square root lesson ka kara grade 10 second lesson. So the value is 4. And 4 kiyane quarter liyan puluwan 4 over 1. It is a fraction, numerator, denominator, integers. Denominator is not 0. So, of course, yes, it is rational. Great. We are doing very good so far. How about this? Is this rational or irrational? Irrational again, is this rational or not? Okay. So a lot of you say no. Why? Because yes. ඒක මම ඉස්සරහට explain කරන්නම් ඔයගලන්ට. ලියන්න එපා. I hope you're not writing anything because I have not given you anything to write yet. මේක ළමයි this is not a perfect square, right? Root of 5 is not a perfect square. Why make a simplify කරොත් ඔයාට එන්නේ something like 2.236 ඔහොමම value එකක් තමයි එන්නේ. The value is going on and on and on and on and on. ගොඩාක් දුරට value එක යනවා. So it goes on and on and on. Okay? Therefore, මේ වගේ එකකට අපි කියනවා මේක අපිට හරියට fraction එකක් විදිහට represent කරන්න බෑ because the value is never ending. The value goes on and on and on. Okay? Therefore, we call this irrational. So we call it not rational. So this is not a rational number. Okay. Examples those we will talk about at a later point. So that is not rational. You identified well. Very good. What do you think about this? Okay. Good. Others? Again, no. 2 is not a perfect square, so its square root also is a never-ending value. Kisima pattern numbers ගොඩක්. So therefore, we cannot call this an integer. The denominator is not an integer. Numerator is of course an integer, but the denominator is not an integer because it's not a perfect square. Perfect square something like this, let's say. Let's say it was something like this. 3/2. So this would be a rational number. But if the denominator has root of 2, square root of 2, that is not rational. Do you understand rational numbers so far? Give me a thumbs up. Risindhi okay, Aiza, Chenuli, Pasindu okay, Metna okay, Denuki okay, Denuri okay, Randira, Sahiru, Randira okay, Sahiru. Sahiru, is it clear? Let me know. So these are what we call rational numbers. Okay. So don't write anything yet. Let me organize the note a bit, what I have written here. And then rational numbers. Let's write a point here. මාතකම ලියාගන්න point එක. Okay, quickly write. Quickly write, Lamai. While you write this, give me a minute. I will be switching off my camera as well, but give me a minute. එතක ඔයගොල්ලෝ මේක ලියා ගන්න. Done writing, Lamai? Let me know when you're done. When you're done, give me a thumbs up. For others, I will give, okay. For others, I will give you 2 more minutes. Make it fast. At the end, Namai, can you all write one sentence here? Yannika sentence එක. All rational numbers can be represented on a number line. All the rational numbers, you can represent them on a number line one way or another. Okay? Quickly write that one point as well. Okay. I think that's enough time. Anybody who needs more time? So done, right? Okay. Maya Hanna. Let's write a topic, irrational numbers. That is the opposite of rational numbers. Irrational numbers, the symbol we say Q dash. Q dash or complement, Q complement, the bar sign. First, let's write a few points and then I will explain. Write these 3 points and then I will explain. Okay. I hope everybody has done writing. Finished? Anybody who needs more time? Okay. So previously, when we were talking about rational numbers, we said that certain numbers don't belong to that rational number category. Those are what we call irrational numbers, right? For an example, if we take something like root of 5, right? If I take the square root of 5, it's something like 2.3606. That's all I remember. 1 second. Let me give you the exact value. 2.23606797. Likewise, this number goes on and on and on. So if I ask you, does root 5 have an exact answer? Right, if I ask you to find the root of 16, you know it's 4. That's a definite answer. Then I ask you to find the square root of 5. For square root of 5 also, there is a definite answer. Have a definite answer. Decimal places we don't know. Because the decimal numbers are going on and on and on. And even if it goes on and on, we can't find an ending. Ending it's too complicated. But is there an ending? There might be. There might be an ending. It's just that we cannot find that ending. Abhi meka divide kara we cannot find the ending because the numbers are continuously occurring. Right? And also, even if you look at these numbers, there is no pattern, just the numbers. Decimal places numbers are very random. See, irrational numbers have multiple numerals in the decimal form with no clear pattern. Clear pattern just randomly numbers are going like that. If I take something like 3 over square root of 2. So if I take, I will give you that value because of course I don't have that value memorized. So 2 get square root take aragena 3 divided by square root of 2. We get something like 2.1213. 2.121320 3435 and so on. The numbers are going on and on and on and on. So there is no clear ending that we can find. There must be an ending somewhere at some point, but we can't find it. Divide we can't find the ending, and ending even then we can't find any pattern. Decimal numbers, you can see there's no pattern. They're just randomly occurring. So these are what we call irrational numbers. So you know pi, right? Pi can value pi, you know pi. Pi value the value is actually given on the textbook. 3.141592653 and so on and on and on. It goes on, right? In the textbook, some of you may have the textbook, but I will get this picture onto the whiteboard. May I will pi value decimal places 60. There are 60 decimal places here. Even then, this is not over. This goes on and on and on, even further. But here we have shown 60 decimal places. But that's not the end. We can divide it further and get more decimal places. And even if you look at these numbers, can you see any pattern? We can't see a pattern. Okay. So pi is also an irrational number. Now you should have a question to ask me. Do you have now when I say pi is an irrational number? When I say pi is an irrational number, do you have any question for me? Do you have any confusions? When I say pi is an irrational number, you should get some question. You should ask me question, and so like some question regarding that, based on what you already know about pi. Can it be a rational number too? No. Okay. So Pasindu says it's a fraction. Why do you say it's a fraction, Pasindu? What is the fraction of pi? Okay. Others, what do you think? I got one good question. Others, what is the question you get when I say pi is an irrational number? Yes, Sahiru. Okay. When we say pi lamai, like in grade 10 also we did like arc length, perimeter and all that stuff. We used pi multiple times. අපි pi වල value එක විදියට ගොඩක් වෙලාවට ගත්තේ fraction එකනේ. What is the fraction of pi? I got two answers. What about others? What is the value of pi? Yes. It is 22 over 7. So now this is a fraction with a numerator and a denominator. Both the numerator and the denominator are integers and the denominator is not 0. So this should actually be a rational number, right? Irrational number. So this should actually be a rational number. 22 over 7 කියන එකම තමයි මෙතන මේ decimal එකක් විදිහට අවිල්ල තියෙන්න ඕනේ හරියන්නේ. Because that is pi, this is also pi. So here I say pi is an irrational number, but here it seems like pi is a rational number. Here's the thing, mama. මෙන්න මේ pi වල value එක I told you the decimal numbers are never ending and goes on and on and on. Right? මේක අපිට fraction එකකින් ලියන්න බෑ. We can't express irrational numbers in a fraction. මේක මට fraction එකක් ලියන්න බෑ. එහෙනම් මම මේ ලියලා තියෙන්නේ මොකද්ද? 22 over 7 is not the real value of pi. අපි මේක approximation එකක් විදිහට තමයි 22 over 7 කියලා ගන්න. It's just a near value. Because otherwise අපිට pi වලට we will never be able to do calculations using pi because pi has like a never ending number of decimals. So we will never be able to use pi for our calculations, right? Therefore, it is just like obtained as a fraction that pi is 22 over 7. So using 22 over 7 as pi, that is not the most accurate value of pi. That is just a close value. Ekahinda pi කියන්නේ irrational number එක. 22 over 7 is a rational number. But 22 over 7 is not exactly equal to pi. So that is about irrational numbers. Did you understand? Give me a thumbs up. Great. අපි points තුන ලියවනේ. මේ examples තුන ලියලා I will write another point at the bottom. Write that point too. First write these 3 examples. So the decimal values are never ending. So we call it infinite. Infinite can infinity when a number sticker. Okay. Quickly write. Make it really fast. One more thing that I want you all to add. add pattern bracket third point examples were calling in the third point we said blah 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 with no clear pattern. There I just want to add a few words within a bracket. No recurring pattern this one on this part. Make a chutta add karagan. And then keep writing. Okay. For those of you who are writing still, I will give you 2 more minutes. Make it really fast. One more minute. Okay. Everybody done? Give me a thumbs up. Anybody who needs more time? Generally, okay. Passing through Dinuki, Randira, done. Okay. We will do a question, and then I also have to show you one more thing here. But before that, I think it's better for us to do a few questions, right? Go to exercise 1.1. For those of you who don't have the textbook, I will get this exercise to the whiteboard. Exercise 1.2, I put it to the whiteboard. I hope all of you can see. Can you all try this? These are very simple. Make questions to harima simple. What you have to do is, these are some real numbers. So you have to write rational or irrational. If this is rational, you write a kila rational. If it's irrational, you write irrational. Then here, just true or false. That's very easy. Can you all quickly do it? I will also set a timer for this. 6 minutes. Make it fast. 6 minutes should be enough, but if you need more time, I will later give you time, but try to finish within 6 minutes. Make it fast. Quickly. About 1.5 more minutes. Done, Lamai? Thumbs up, please. If you have finished, or do you all need more time? If you all need more time, tell me. Okay, seems like most of you are done. Risindi Dinuki? Okay, okay, great. Then let's discuss. Okay. Root 2, is it rational or irrational? Root 2, is it rational or irrational? Pick it up. Okay, others? Yes, it's irrational. Root of 25, rational or irrational? Others? It is rational, yes. Root of 25 is exactly 5. 5 you can write as 5 over 1, so it is definitely rational. Root of 6, rational or irrational? Yes, it is irrational. Root of 11? Again, irrational. 6.52? 6.52? Others? 6.52, did you put rational or irrational? This is rational, Lama. Yes, this is rational. Why do I say 6.52 is rational? Look at this. 6.52 like this. So this is a fraction. The denominator is an integer. However, the numerator is not an integer. However, මට මේ decimal point එක අයින් කරන්න මෙයාව 100 ගේ multiply කරන්න පුළුවන්. So if I do something to the numerator, I have to do the same to the denominator. Then I get 6.5 to 100 වලින් multiply කරාම decimal place එක points දෙකකින් පිටිපස්සට යනවා. That would be 652. 1 multiplied by 100 would be 100. See, this is a fraction. Numerator, denominator both are integers. Denominator is not 0. Therefore, this is definitely rational. Okay. All right. Next one. Determine true or false. Determine whether each of the following statement is true or false. A, any real number is a finite decimal or an infinite decimal. Is it true? Any real number is a finite decimal or an infinite decimal. Is it true? Okay. Others? Okay. Seems like most of you are on the right track. Hmm? What about others? Anitha answers komada. I just want to hear all your answers actually. This is yes. Good Lamaya. This is true. Ekko decimal ekko hari that is finite, or the decimal will go on forever until infinity, that is infinite. It should be one of the two. Ne? So definitely this is true. There can be rational numbers with infinite decimals representations. This is actually a very good point. With this, I will explain you something as well. But what did you put here? What did you put here? So Megha, the last part that I had to teach you, I think we need that for this. මේ ටික අපි චුට්ටක් තියමුද? Because the first few the first question we can do with the current knowledge, but we need that last bit to do the true or false statements. So I didn't read it properly. මේක අපි කරමු. So ඔයගොල්ලන්ගේ answers ටික තියාගන්න. So we can re-evaluate the answers. Keep those answers, and keeping them, we will move on to the next section. Can you all put a topic? අපි rational numbers කතා කරා, irrational numbers කතා කරා. Can you all put a topic real numbers? This second question we will discuss in a bit. Huh? Put the topic real numbers. Real numbers. The symbol of real numbers is capital R. Real numbers. Now, my real numbers කියන්නේ all numbers. Whether it's integers, whether it's like positive integers, negative integers, or zero, whether it's natural numbers, whether it's rational numbers, whether it's irrational, all numbers are real numbers. Okay. So let's write a point. All numbers are real numbers. Therefore, both rational and irrational numbers belong to real numbers. So it's very easy. Okkoma numbers, all the numbers that we're learning, whether it's rational or irrational, they're all real numbers. Quickly write these 2 points, and then I will show you something. Okay. So, Lamai, if we say all numbers are real numbers, I'm going to show all of this like real numbers, rational, irrational. Okkoma mama Venn diagram making uganda pennana hada. Okay. So, if I use this square to represent all the real numbers. So, as I said previously, real numbers are all numbers. All the numbers are real numbers. So this square represents real numbers. Real numbers. Capital R, represented by capital R. Inside real numbers, මම මෙන්න මෙහෙම circle එකකින් පෙන්නනවා. These are rational numbers. These are rational numbers. Because rational numbers are inside real numbers, right? Because rational numbers belong to real numbers. Represented by capital Q. So, Lamai, so inside this circle, this entire circle represents rational numbers, right? This entire circle represents rational numbers. So these are all rational numbers. Then what will be represented by the outside? What will be represented by this outside part? If this circle represents all the rational numbers, what is the outside part going to represent? This is what I'm shading in yellow. Yeah. Yes, Sahiru, others? Yes, Denuri? Yes, Mepna? Lamai, all numbers are real numbers, ne? Right? I told you all numbers are real numbers. So if a part of real numbers represent rational numbers, whatever that doesn't belong in the rational numbers should be irrational numbers, right? Therefore, yes, whatever is shown in yellow is actually irrational numbers. Correct. Irrational numbers. So rational numbers තියෙන set එකට අපි Q කියලානේ කියන්නේ. So whatever that doesn't belong in the Q, we call it complement of Q. ඒකයි අපි rational numbers වලට Q dash කියලා කියන්නේ. All right. Okay. Okay. Now, inside rational numbers, we have another small set. Inside rational numbers, we have another small set. This we call integers. Integers represented by Z. So that means there are rational numbers that cannot be integers, right? Yeah, the rational number. Now let's say for an example, if you take 3.5, is this an integer, Lamai? Is 3.5 an integer? Others? Is 3.5 an integer? No. Is 3.5 a rational number? Is 3.5 a rational number? Yes. Therefore, there are certain numbers which are rational numbers, but they're not integers. So they are in the circle of rational numbers, but they're not inside the circle of integers. So they belong there. So then this circle is all integers. This circle is all integers. All right. Inside integers, there is another small section. මේකට මම කියනවා natural numbers. Natural numbers symbolized by capital N. And I told you earlier, natural numbers කියන්නේ positive integers. නේද? So අපි examples ලියාගෙන ගියෝ. Just let's write a few examples. So 1, 2, 3, they are all positive integers, therefore they are natural numbers. Then what are integers that are not natural numbers or that are not positive integers? We can write -2, -10, then 0, -100. They are integers, however, they are not positive integers. Okay. Then what are rational numbers but are not integers? As I said, 3.5. Then if you take like half can 0.5. Ne? That is still a rational number but is not an integer. Then there are others that are real numbers but are not rational numbers. We call them irrational numbers. Example, √5, √2, pi, √11. These are some examples. Did you all understand this Venn diagram? Give me a thumbs up if you understood. Okay. Then can you all quickly start writing? Ek point එකකුත් යටින් ලියා ගන්න. The square roots of all numbers except for perfect squares are irrational numbers. ඒ කියන්නේ perfect squares අරගෙන අනිත් හැම square root එකක්ම. Like if you take square root of 16, that is a perfect square, so it's 4, no problem. If you take the square root of 100, it's 10, it's a perfect square, so no problem. But all the other numbers like square root of 2, 5, 6, 7, 8, 11, 12, 13, they're all irrational numbers. Harry. So can you all quickly draw this Venn diagram, mark everything, mark the examples, all of that, and then write this point as well. For this, I will give you 6 minutes. Make it really fast. 6 minutes. Quickly, chop, chop. While you write this, give me a minute, Lamai. Lama, you have like 50 seconds more, roughly 1 minute. Everybody finish? Done? Give me a thumbs up if you have finished. Okay. Denuri, Randira, Sahiru. Sahiru? Let me know. Okay. We'll move on to the next part. Write a subtopic decimal representation of a number. This is also very easy. Let's quickly finish this. Decimal representation of a number. Okay. Under that, I want you all to write a subtopic. Subtopic ek daganna. Number 1, decimal representation of a rational number. Number 1 kira subtopic ek daganna. Decimal representation of a rational number. All right. So let's consider some rational numbers. For this, I'm going to use the same examples as on the textbook because all the lengthy decimal points okkuma textbook ke examples wala thiyena hinda we'll use those same examples, right? Now for an example, one ekak tamai number 5. And you know number 5 is a rational number because number 5 you can express as 5 over 1. Numerator, denominator both are integers and the denominator is not equal to 0. Therefore, this is a rational number. How do I write 5 as a decimal? Can I write 5 as a decimal number? Can I write 5 as a decimal number? Can I? Based on what you know, can I write 5 as a decimal number? How? If you say yes, how? Yes. When I write 5 as a decimal number, I can write it as not 0.5, 5.0. Can I write it as 5.0000? May 5. Is this correct? Is this correct? What do you think? Others, what do you think? Is this correct? It is correct. 5 කියන එක මට 5.0 කියලා කියන්නත් පුළුවන් 5.0000 කියලා ඕන තරම් zeros ගොඩක් ලියන්න පුළුවන් because zeros don't hold a real value here. මට ඕන තරම් zeros ගානක් මේක add කරන්න පුළුවන්. Okay? So I can even write an infinite number of zeros and it will still be okay. Because 5 is anyways a rational number. Nobody can change that. If I want to represent 5 as a decimal, මට පුළුවන් 5.0 කියන්නත් පුළුවන් 5.000 කියන්නත් පුළුවන් ඕන number ඕන zeros ගානක් I can add. Okay? So, if I take something like this, you know this is a rational number because there is a numerator. It's a fraction with a numerator and a denominator. Both the numerator and the denominator are integers and the denominator is not equal to 0. Ek na pe requirements take. So this is a rational number. How do I express this as a fraction? Sorry, decimal. How do I express this as a decimal? How do I express this as a decimal? Yes. 3/4 I can express as, what do others think? Ekai mata answers aave. Quickly tell everybody. Hmm? 0.75. You just have to divide 3/4. You get 0.75. So 0.75 ඕන්න මට මෙහෙම ලියන්න පුළුවන් නේද? 75 ඕන්න මට මෙහෙම zeros ඕන තරම් ගානක් add කරන්න පුළුවන් because zeros really don't hold a value at the end of a decimal, so I can add as many zeros as I want. It will be okay. It doesn't change the value. It will still be 0.5 and it will still be 3/4, so it's a rational number. Okay. Then this example I'm taking straight away from the textbook. Textbook that's why. So let's get 11/8. 11/8. 11/8 වලට when you divide 11 by 8 you get the answer 1.375. Okay. මේක ඔයාලට ඕන නම් මෙහෙම ලියන්න පුළුවන්. 1.375. You can add as many zeros as you want at the end. When you add zeros at the end of a decimal, it doesn't really hold a value. What one zeros 100 million add karat kamak na. It doesn't change the value. It will still be 1.375 and that will still be 11/8 and it will be a rational number. So it doesn't matter. What about something like this? Now this is slightly different. Again from the textbook. 211 divided by 99. ඔයාට මෙන්න මෙහෙම value එකක් එනවා. 2. Now, first of all, tell me, is this a rational number? Is this a rational number? Is this a rational number? Yes, it is. It is a rational number. So, 211.99 divide from, I get a value like this. 2.13131313 and it continues. 131313 දිගටම A pattern එකම තමයි යන්නේ. 2.1313131313 and so on. So here you might get a bit confused because irrational numbers the decimal points are never ending and going on and on and on till infinity. But remember, Lamai, when we were talking about rational numbers above here, we said irrational numbers, irrational numbers have multiple numerals in the decimal form with no clear pattern, no recurring pattern. Since the decimal numerals of an irrational number are not finite, they're never ending, so we call them infinite. So irrational numbers, decimal points are never ending. They can go on till forever. In rational numbers also, there are instances like that. 131313, the decimal points are never ending. It goes on till infinity, goes on forever. However, there is a recurring pattern. 1 3 1 3 1 3. There is a pattern that recurs. Recur කියන්නේ repeat වෙනවා. Recurring means repeating. So there is a repeating pattern. So even though the decimal numbers are like infinite, there is a recurring or a repeating pattern. So it is also a rational number. Let's take another example. Look at this. Again from the textbook, 767 divided by 150. So you get 5.113333 and so on. Now if you look at this 1 it's just 5.11, but look at this number 3 3 3 3 3 3 3 3 3, it goes on as 3 3 3 3 it's an infinite decimal still. However, there is a recurring pattern, a repeating pattern. So there is a recurring pattern that is still a rational number. Anyways, looking at the fraction, you can say it is a rational number, right? Then another example, now look at this one. Again from the textbook, 37 divided by 7. 5.2857, 5.28, 5714, 5714, 2857. And this goes on and on and on till infinity. So this is still an infinite decimal. Looking at the fraction, is this a rational number? Looking at the fraction, is it a rational number? Looking at the fraction, is it a rational number? Looking at the fraction, decimal just look at the fraction. Fraction it looks like a rational number. You can see it is a fraction with a numerator and a denominator. Both the numerator and the denominator are integers, and the denominator is not equal to 0. So looking at the fraction, it's a rational number. But looking at the decimal form, it goes on and on and on. It's an infinite decimal. So at a glance, this is an irrational number. This is not rational. However, is there a pattern here? Can you see a recurring pattern here? If it's a rational number, there has to be a recurring pattern. Yes. Others? Generally can see a recurring pattern. What do others think? Can you all see a recurring? Hasindu also can see. Aiza Dinuki can see. Risindi Metna can see. Yes. What is a recurring pattern? 285714 and again 285714 and again 285714, and that continues. So at a glance, pattern at a glance, it seems like it's just an infinite decimal with random numbers. So we already know if it is an infinite decimal with random numbers, it is an irrational number. However, if you look at it properly and carefully, you can see there is a recurring pattern, a repeating pattern. Therefore, this is also a rational number. So, my rational number, it can be a decimal like this. The decimal ends, no? This is also an ending decimal. It's not never ending and going on and on and on. Make it end make it end. We call these finite decimals, right? We call them finite decimal. or we call them terminating decimal. We call this, even this, මෙතන 0 එකක් තියෙනවා, එතනින් එහාට නැහැ. It's just zeros and that's all, right? So we call them finite. ඉවර වෙනවා. decimal එක ඉවර වෙනවා. Finite decimal, or we can also call them terminating decimal. ඉවර වෙනවා. Terminating means ඉවර වෙනවා, no? Terminating decimal. I hope my handwriting is readable. However, if you look at these three, the decimals are never ending, no? They're going on and on and on. So they're never ending. We call them infinite. Infinite unata, they have a repeating pattern. Infinite, but there is a repeating pattern. So we call them recurring decimals. Infinite, but recurring. Right? We call these. So mewata kiyanne finite or terminating. These are called recurring decimals. Recurring kiyanne repeating pattern ekakin digatama continue වෙනවා. Recurring decimals. So they go on till forever. Recurring, but they're infinite. Infinite means ඉවරයක් වෙන්නේ නැහැ. Up to this point, is it clear? Give me a thumbs up, please. Dinuki, Ramdira? Ramdir, is it clear? Okay, great. Can you all start writing this then? Quickly start writing. If you have any questions, please do ask. හිතේ තියන් ඉඳලා වැඩක් නැහැ questions if you don't ask. අන්තිමට 0 විතරයි නම් ඉතුරු වෙන්නේ. It's a finite or a terminating decimal. If the pattern repeats, it's a recurring decimal. For those of you who are still writing, I will give you 1 more minute. අපි rational decimal representation අත ඉවර කරා අද ඉවර කරමු. Usually for the newcomers the class go till from 7 p.m. till 9:30 p.m. but like විනාඩි 5ක් 10ක් යහලා මෑට වෙන්න පුළුවන්. Okay, 1 more minute. Also, I have some interesting news for you all. September or September the September I introduced you all the AI and I told you all how to use the AI. So we are working on it. We keep on working on it and improving it. And Milangadi, there was an improved version that came out, and there's going to be another better version in I think another 1 week or so. In addition to that, there's something interesting, but this is in terms of science. Ogalanta access denang maths I hamotam access denang ekata. Can you all hear me? Please give me a thumbs up if you can hear me. Okay. I'm sorry I got disconnected. It's raining outside, so I have a bit of a network issue. So I was telling you guys about the AI and how it keeps on improving. So in a week or so, there will be an improved version coming out. Mahitane samharata mang already access දීලා ඇති access දීලා නැති කවුරු ඉන්නවා නම් මට newcomers කාටවත් access නැතුව ඇති. For all the newcomers I will give access. Anyways, what I was going to tell you is that there's going to be something interesting, especially for science. There's going to be like an MCQ revising, lesson wise MCQ revising. So I'll lesson එක select කරාම ඔයාට MCQs එනවා, you can select the answers, and there's like an MCQ game. ඔක්කොම MCQs O level past papers වලින් lesson wise ගන්න MCQs. So I think it will be interesting for you all. මම හිතන්නේ next week වගේ ඔයගන්ට මට එක introduce කරන්න පුළුවන් වෙයි. And also mid January වගේ there's also going to be flashcards. Flashcards now maths and science දෙකටම දෙනවා. Even for maths there will be flashcards. So yes, as soon as they are released, they come out, I will let you guys know. Okay? So I think both MCQ game and the flashcards will be interesting for you all. Rather than the AI, ඔයගොල්ලන් ගොඩක් use කරන tools දෙකක් වෙයි ඒ දෙක. මම ඔයගලන්ට ඒක අහම කියන්න. කියලා I will give you access and all that. Okay? All right. So put a subtopic. This is decimal representation of a rational number. So far we did. No. Don't put a topic. So here, Lamai, now when you talk about recurring decimals, it's very annoying, right? Now for an example, if you take this one. If you take this one, so if you take 5.11, then 3, and so on, right? So this one, it's very difficult to write. It's very difficult. So we can shorten it when writing. How are we going to shorten it? 5 recurve එක විතරයි. දැන් මේ 5 කියන එක recurve වෙන කෙනෙක් නෙවෙයි. So I write 5 as it is. Point 1 කියන දෙන්න recurve වෙන්නේ නැහැ. It's just 1 and that's it. But මේ 3 කියන number එක එක දිගට repeat වෙනව නේද? The number 3 keeps on repeating. So what I'm going to do is I'm going to write 3 here and I'm going to put a dot on top of it. A little dot on top of the 3. So what that indicates is that the number 3 keeps on repeating. කියන එක තමයි ඒකේ meaning එක. Okay. For an example, now this is something from the textbook. If I say 12.4, 4, 4, 4, and so on, මට මේක ලියන්න පුළුවන් 12.4 කියලා 4 උඩ මෙහෙම dot එකක් තියෙනවා. So that means the 4 keeps on repeating, right? So this is a shortened way to write this. මොනවත් ලියන්න එපා දැන්ට ළමයි, yeah? I have to write a point before this, so don't write anything and just listen. What about something like this? Here we have 2.131313 part. Let's see how we are going to write that. 2.131313 and so on. ඒක අපි ලියන්නේ මෙහෙම. 2. මේ 1 3 කියන එක නේද repeat වෙන්නේ. This 1 3 part is the one that is repeating. Okay? So I write 1 3. May repeat when a patangane 1 valley. The repeating section starts with 1 and ends with 3. So I put a dot above 1 and I put a dot above 3. That means that 1 3 section keeps on repeating. The 1 3 section keeps on repeating. How about something like this? This one. So yeah, in 5.285714 285714 and so on. මෙයාම මට ලියන්න පුළුවන් 5 what is the repeating unit? 285714 is a repeating unit. Again, I have 285714, that is a repeating unit. So, mama, එක repeating unit එකක් ලියනවා. 285714. Where that repeating unit starts, that is 2. ඒක උඩින් මම එක dot එකක් තියනවා. Where the repeating unit ends, that is 4. එතනින් මම තව dot එකක් තියනවා. So here, what that means is that this particular repeating unit, 28574, will keep on repeating. Oh, mama, repeat when. That's what it means. Okay. Methana 1 udinuයි 3 udinuයි dot එක තියෙන්නේ. That means that 1 3 part keeps on repeating. That keeps on repeating. That's what it means. Here 4 udin vitarai dot එක තියෙන්නේ. That means 4 keeps on repeating. Okay. Here 3 udin vitarai dot එක තියෙන්නේ. That means 3 keeps on repeating. Is that clear, lamai? This is how you write it short or in a concise manner. Shorten kala, concise kala liyane mehema. Is it clear? Give me a thumbs up, please. මේ point එක ලියා ගන්න. And then write these examples really fast. Feel like we might not be able to do irrational numbers part today, but we'll see. Quickly write this, Namai. I'll give you 2 minutes to write this. Make it fast. Okay. Done, everybody? Give me a thumbs up, please. Denuri, Risindi, Sahiru, do you need more time? Denuri and Sahiru? All right. So, Lamai, with that, we will end the class for today. Wait, don't leave. So, before we end the class, so Aiza and Dinuki, since it's your first day, let me know whether you will continue the class or not. Let me know on WhatsApp within today and tomorrow. Okay. And also, I think I had something else to tell you all. I can't remember. I think that's all. Yeah. So, Aiza and Dinuki, let me know whether you will continue or not. And I think that's all I have to tell y'all. We will be meeting on 12th of January, which is next week, Monday. And the whiteboard note I will send in the group. So may අවුරුද්දෙන් මං හිතුවා හැම week එකම අනිවාර්යයෙන්ම whiteboard note එක එවනවා කියලා, because in the past I don't know for how long I have not been sending the whiteboard note ne. So sometimes I think you might need to recheck your note and see if there's any errors or anything like that. So better to have it. Okay, so I will send the whiteboard note. And also another thing that I decided was that may අවුරුද්ද මම හරියටම attendance sheets ටික mark කරන්න ඔයගොල්ලන්ගේ කියලා, because that's very important for both you and me. Okay, so yeah, that's all. We will meet each other next week. So until next week, have a great one, have a great week, and good night, Lamai. Thank you. Okay. Yeah, happy new year to you too. Have a great year. 2026 will be great.